The moment you were born, you began to die. Not metaphorically. Physically. Thermodynamically. From the instant your first cell divided, you have been fighting a battle you cannot win. A battle against equilibrium. Against uniformity. Against the most fundamental tendency in the universe. And the strangest part? That battle is not a flaw in the design of life. It is life itself. This is a story about why you exist. Not in the sense of purpose or meaning, but in the most literal physical sense. Why the molecules in your body are arranged the way they are. Why they move. Why they must keep moving. And why, if they ever stop, you cease to be. Let's start with a question that sounds simple but cuts to the heart of everything. What is equilibrium? Most people think of equilibrium as balance. Stability. A peaceful state where nothing changes. And in a sense, that's correct. But equilibrium is not peaceful. It's the opposite. Equilibrium is death. Thermodynamic equilibrium is a state where there are no energy differences anywhere in a system. No temperature gradients. No chemical potential differences. No concentration gradients. Nothing flows. Nothing reacts. Nothing changes. Imagine a room where every molecule of air has exactly the same energy. Every corner is the same temperature. Every particle moves with the same average speed. Nothing would happen in that room. Ever. A candle could not burn because there would be no chemical energy gradient between fuel and oxidizer. A human could not survive because there would be no difference between the energy inside cells and outside cells. No metabolism. No respiration. No thought. Equilibrium is not chaos. It is the opposite. It is maximum entropy. Maximum uniformity. Perfect, absolute, unchanging sameness. And in that sameness, nothing complex can exist. Here's what's strange about entropy. We've been taught to think of it as disorder. Messiness. Randomness. But that's not quite right. Entropy is a measure of how spread out energy is. How evenly distributed. How uniform. A hot cup of coffee has low entropy compared to its surroundings. The thermal energy is concentrated in the liquid. There's a gradient between the coffee and the air. As the coffee cools, that energy spreads. It flows from the cup into the room. The temperature evens out. Entropy increases. When the coffee reaches room temperature, it has reached equilibrium with its environment. Maximum entropy. Maximum uniformity. And at that point, nothing else happens. The coffee doesn't spontaneously heat back up. It doesn't separate into layers. It just sits there. Uniform. Unchanging. Dead. This is the second law of thermodynamics in action. Not a tendency toward chaos, but a tendency toward sameness. And here is the crucial point: life cannot exist in sameness. Think about what you are. Not philosophically. Physically. You are a collection of molecules arranged in an extraordinarily improbable configuration. Your cells maintain chemical concentrations that are wildly different from your surroundings. High potassium inside. High sodium outside. ATP molecules packed with chemical energy. Proteins folded into precise three-dimensional structures. None of this is equilibrium. All of it requires constant energy input to maintain. Your body temperature is higher than the environment. That's a thermal gradient. Your cells have different ion concentrations than the fluid around them. That's a chemical gradient. Your muscles store potential energy in molecular bonds. That's an energy gradient. Every single one of these gradients wants to collapse. Thermodynamics demands it. The heat wants to escape. The ions want to equalize. The chemical bonds want to break down into simpler, more stable molecules. And if you stopped eating, stopped breathing, stopped metabolizing energy, that's exactly what would happen. Within hours, your temperature would drop. Your ion pumps would fail. Your ATP would deplete. The gradients would collapse. You would reach equilibrium with your environment. And you would be dead. So here's the question that changes everything. If equilibrium is the natural state, if entropy always increases, if energy always spreads out and gradients always collapse, how does life exist at all? The answer was discovered by a Belgian physicist named Ilya Prigogine in the 1960s and 1970s. Work that would eventually win him the Nobel Prize. He called them dissipative structures. These are systems that maintain their organization not by resisting thermodynamics, but by accelerating it. A candle flame is a dissipative structure. It maintains its shape, its temperature, its chemical reactions, not by being in equilibrium, but by being as far from equilibrium as possible. Energy flows through the flame. Chemical potential energy in the wax converts to heat and light. That energy radiates outward. The flame maintains its structure by dissipating energy into its surroundings. The moment the energy flow stops, when the wax runs out, the flame disappears. Not gradually. Instantly. Because the flame is not a thing. It is a process. A pattern sustained by energy flow. And so are you. Your cells are dissipative structures. Your organs are dissipative structures. Your entire body is a dissipative structure. You maintain order by consuming energy. By breaking down food molecules. By using that energy to pump ions, synthesize proteins, repair DNA, generate heat. And in doing so, you produce entropy. Not just a little. A lot. Far more than if you didn't exist. When you metabolize glucose, you break stable carbon-oxygen bonds and form even more stable carbon dioxide and water. You extract energy from the gradient between those molecular states. You use that energy to maintain your internal gradients. But in the process, you release heat. You exhale gas. You produce waste. All of that increases the entropy of your environment by more than your body decreases its own internal entropy. Life does not violate the second law. Life accelerates the second law. You exist because you speed up the universe's march toward equilibrium. Let's go deeper. Why does energy flow matter so much? Why isn't heat alone enough? Because life doesn't just need energy. It needs useful energy. Energy that can do work. Heat is energy, yes. But heat in equilibrium is useless. If everything is the same temperature, thermal energy cannot flow. It cannot drive reactions. It cannot be harnessed. What life needs is a gradient. A difference. A flow. On Earth, that gradient comes primarily from the sun. But not the way most people think. The sun doesn't warm the Earth and therefore life exists. That's too simple. What matters is that the sun is hot and space is cold. The Earth sits in between. It absorbs high-quality, low-entropy energy from the sun in the form of visible light. It uses that energy to drive photosynthesis, weather, ocean currents, and ultimately all biological processes. And then it radiates that energy back into space as low-quality, high-entropy infrared radiation. More photons leave the Earth than arrive. Lower energy per photon. Higher entropy. The Earth is a dissipative structure. It maintains complexity by channeling energy from a hot source to a cold sink. Life exists in that flow. Not at the hot end. Not at the cold end. In the middle. In the gradient. Now think about what happens when the flow stops. Imagine you place a living cell in a perfectly insulated container. No energy can enter. No energy can leave. At first, the cell continues to function. It metabolizes stored energy. It maintains its gradients. But it cannot replenish that energy. And it cannot export the entropy it produces. Waste products accumulate. Heat builds up. The internal environment becomes more and more uniform. The gradients collapse. The cell dies. Not because it ran out of matter. The atoms are all still there. But because it reached equilibrium with its immediate surroundings. This is the physical definition of death. Not the cessation of heartbeat or brain activity. Those are consequences. Death is the loss of internal energy gradients. The equalization of chemical potentials. The uniformity of molecular distribution. Death is equilibrium. And life is the sustained resistance to equilibrium through energy flow. But here's the unsettling part. That resistance is temporary. Necessarily temporary. Every living organism is a dissipative structure. And dissipative structures require external energy sources. When those sources run out, the structure collapses. For a candle, it's when the wax is consumed. For a cell, it's when ATP depletes. For a human, it's when metabolism can no longer be sustained. And for the universe? Stars are dissipative structures. They maintain their form by fusing hydrogen into helium, releasing energy, radiating it into space. But stars run out of fuel. Eventually, every star will exhaust its nuclear reserves. It will either explode as a supernova or cool into a white dwarf, a neutron star, or a black hole. And when all the stars are gone, the universe will grow dark. Cold. Uniform. The last energy gradients will dissipate. The last flows will cease. Equilibrium. Maximum entropy. Not chaos. Not disorder. Just sameness. And in that sameness, no life can exist. No structure. No complexity. Nothing that we would recognize as interesting. This is the heat death of the universe. The inevitable end state predicted by thermodynamics. A cold, dark, uniform expanse where nothing ever changes again. So life exists because the universe is not yet in equilibrium. Because there are still stars. Still energy gradients. Still flows from hot to cold, from high concentration to low, from chemical potential to kinetic energy. We exist in the brief, cosmically temporary window when energy still flows. And not just exist passively. We are active participants in that flow. Every breath you take, every thought you think, every movement you make accelerates the universe's journey toward equilibrium. You are not fighting entropy. You are entropy's agent. You exist because you speed up the inevitable. There's a strange beauty in this. Life is not an anomaly. Not a violation of physical law. Not something that shouldn't exist according to thermodynamics. Life is exactly what thermodynamics predicts. When you have a system far from equilibrium, when you have energy flowing through it, complex, self-organizing structures will emerge. Not despite the second law. Because of it. Because those structures are efficient entropy producers. They channel energy flow. They accelerate the journey toward equilibrium. A barren planet would eventually radiate the sun's energy back into space. But it would do so slowly. Inefficiently. A planet with life does it faster. More completely. Photosynthesis captures solar energy. Food chains transfer it. Metabolism converts it. Waste heat radiates into space. Life is not a brake on entropy. Life is entropy's engine. And yet, here's the paradox. We experience life as vitality, motion, complexity, the opposite of decay. But physically, we are decay. Controlled decay. Organized decay. We are flames burning bright, maintained by the fuel of food and the oxygen in air, radiating entropy into the universe. The more alive we are, the more entropy we produce. The more we accelerate the universe's march toward its ultimate fate. A sprinting cheetah produces more entropy than a sleeping one. A thinking brain produces more entropy than a dormant one. Life at its most intense is entropy production at its most intense. We are not separate from the second law. We are its most exquisite expression. So when people ask why we exist, the answer is not mystical. It's not teleological. It's thermodynamic. We exist because the universe is out of equilibrium. Because stars burn. Because energy flows. Because gradients exist. And we exist to dissipate those gradients. To channel energy from high-quality states to low-quality states. To accelerate entropy production. Not by design. Not by purpose. By inevitability. When energy flows through matter, complex structures will self-organize. They have to. Because that's what far-from equilibrium systems do. And the more complex they become, the more efficiently they dissipate energy. The more entropy they produce. Life is not an accident. It's a consequence. A necessary consequence of physics in a universe far from equilibrium. There's one more implication we need to consider. If life is sustained by energy gradients, and if those gradients are temporary, then life itself is temporary. Not just individual organisms. Not just species. Not even just life on Earth. All life. Everywhere. In the entire universe. Eventually, the gradients will run out. The stars will die. The energy flows will cease. And when that happens, life, all life, will end. Not because of some catastrophe. Not because of extinction. But because the physical conditions necessary for life will no longer exist. This is not pessimism. It's thermodynamics. But there's something profound here. Life exists in the window between the Big Bang and heat death. In the era when the universe is still far from equilibrium. When stars still shine. When energy still flows. We exist in the most interesting epoch of cosmic history. The epoch when complexity is possible. When structure can form. When matter can organize itself into patterns that compute, observe, and reflect. We are not watching the universe from outside. We are the universe watching itself. And we can only do that because entropy increases. So here is the final truth. You exist because you accelerate entropy. Because you dissipate energy. Because you are far from equilibrium. The gradients that sustain you, thermal, chemical, electrical, are temporary. Fleeting. Constantly collapsing and being rebuilt by metabolism. The moment they stop, you stop. Life is not a stable state. It's a process. A flow. A brief, brilliant pattern in the river of energy moving from stars to the void. And in that pattern, something extraordinary happens. Matter becomes aware. It thinks. It questions. It discovers the very laws that govern its own existence. We are dissipative structures that have learned what dissipative structures are. We are entropy's way of accelerating itself while simultaneously understanding that acceleration. And perhaps that's enough. Not purpose. Not destiny. But something more subtle. More profound. We are the universe's brief moment of self-reflection. A temporary eddy in the flow toward equilibrium. A pattern that persists just long enough to recognize its own impermanence. Life exists because entropy increases. And life understands itself because entropy allows complexity in the space between order and chaos. We are that space. Finite, temporary, beautiful, and entirely, perfectly, inevitable.